Hi everybody, my name is Nathan Glover, and today I'm going to talk to you about the top 5 tips that I think you should know about for scaling your IoT projects. I work for Mechanical Rock. I'm a DevOps or senior DevOps consultant, and I specifically love IoT and just like getting my hands dirty with projects at home, hobbyist things. So let's talk about our hypothetical company before we get started. So we are Planet Toast. We are the world's most innovative internet-connected toaster company. What that means is that, well, I guess to bring it back to the start, we are a startup. We've only just begun our journey, and we've decided we're going to design internet-connected toasters. We've got a little bit of skills in IoT. We know some stuff. We've worked with cloud a little bit, but we're not too sure how we're going to make this work for our customers and how we're going to make sure that their data is secure, we're able to ingest information that's relative to us, and to make sure that we ultimately don't burn toast. So let's talk about our first tip, and that is connecting securely. Now, when I say connecting securely, I don't typically mean taking the toaster into, a secure data center and plugging it in over Ethernet, because that's just not practical. The reality is, these toasters are going to be out in the wild in customers' kitchens being used. There's no way of us knowing how secure their LAN environment within their house is going to be, so we can't make assumptions about their security. We need to take matters into our own hands. So let's talk about how we connect securely to the cloud. Now, when we're using AWS IoT Core, we make use of these X509 certificates. Now, these certificates themselves are attached to roles and policies that allow them to access certain resources within AWS and locks them out from anything else. So what we're going to do is we're going to have a bunch of these certificates, a bunch of policies, and a policy per device that's attached to each of these toasters. Now, those devices themselves connect over a public access point that's unique to your account and uses those certificates along with the Amazon Managed Certificate Authority to verify that your device is the correct device able to talk back and communicate. So there's other routes we can take as well. There's IoT Edge versus IoT devices. So maybe our toaster itself needs to have extra components inside it that allow them to also talk back to AWS, for example. So maybe the heating element is actually a separate IoT device that also needs to talk back to AWS. So you could do this a few different ways. You could have that heating element be another device that gets another certificate and another policy. And in this case, that's what I've got here. So we're talking about IoT devices and not edge devices, and that basically means you need 2 certificates for 2 devices. Maybe you only have 1 device, and in our case, since we only have 1 device, the IoT device might make a lot of sense. It provides us bidirectional communication over MQTT and allows us to send data about how toasty the toast is, for example, and it also allows us to receive commands like power on to tell the toaster to do something. Now, when we talk about IoT edge devices, this is where I'm starting to talk about that heating filament. Maybe it needs to also talk back to AWS. You might want to sense and actuate with a bunch of different pieces attached to your toaster. Edge might make a lot of sense because you can actually have 1 certificate on that main device in the middle, and then all the surrounding devices can talk to that middle device and use that as its sort of arbiter of information. So that allows it to, it sends its data to the middle, and the middle handles the communications back to AWS. Usually you'll find edge devices used in situations that aren't toaster related because they offer other unique abilities like resilience to network outages. Because the core device can kind of handle the flow and handle the offline communication of devices, you could be disconnected from the internet and that edge device is still able to operate. So let's talk about device management, because I think this is by far one of the most important tips that you need to think about when you're building out your IoT solutions. If every single house needs to have a toaster, that means every single one of these devices will need to have a unique certificate, a unique identity per se. You can't just use the same identity across all the houses, because then how do you distinguish between them? Now, I like to say that sometimes standards are a really good thing. As you can see here on the right, we've got a bunch of different devices, and perhaps a few different teams are working with these devices, and they all name them different things, and by extension, they also name the certificates different things. So you're going to have a bunch of different standards, no one's conforming to anything, and it becomes pretty confusing pretty quickly to work out how you're going to name your things if you're overlapping with other things that might already exist. And there's no real way of determining like which customer has which device, for example. And that's where I think the power of a certificate vending machine really comes into play. So the certificate vending machine is actually a AWS solution to this problem. They've got an open source repository for CVM, certificate vending machine, and it allows us to harness the power of a small little CloudFormation stack that allows us to vend certificates out for new devices. So it creates certs, it creates policies, and it creates the things in AWS IoT Core for us to attach those certs and policies to. It scales really, really well for most projects as well, especially if you're a home hobbyist. Even if you are a home hobbyist, I should say, you should look into certificate vending machine, because it allows you to quickly create a certificate that you know is secure and safe, and maybe for all your hobby devices, you have all those certs managed for you in DynamoDB. I find this particular stack to be really, really handy, and like I said, whether you're a business or a hobbyist, you should definitely look into this. It's all CloudFormation managed. You just deploy a stack, you get an API gateway endpoint, and what you do is whenever you want to create a new device, you create an entry in DynamoDB for that device with like a verification ID, and then you make a request over the HTTP endpoint, providing the verification ID and the device ID, and then it sends you back the certificate information over HTTPS for you then to use on the device. Now, the certificate vending machine works pretty well in most scenarios. However, I found that vending like hundreds and hundreds and hundreds of these things, the CVM has some limitations, specifically around if you want to use Greengrass, because the certificate vending machine only creates things, policies, and certificates, whereas the Greengrass vending also requires a Greengrass group to be put on top of that, which CVM doesn't support. So I've actually created an open source project called AWS Greengrass, which is a CDK stack that handles the creation of Greengrass groups and manages the deployments for you. You can also do this via CloudFormation as well, and there's plenty of open source solutions for those too. However, for the example that I've used, I've created it in CDK because it allows me to programmatically create new devices without too much extra YAML. So a device is vended and then it is attached to a Greengrass group core. And then basically whenever you make changes to like Lambda code that needs to run on the edge, it's all managed for you through CloudFormation under the hood. It'll also automatically clean up devices, certificates, roles when you delete the groups and devices from the stacks. So all that stuff is kind of handled for you. You don't need to go click ops anything. It's quite nice, and I'll have links to this particular repo at the end of the end of this presentation. So let's talk about tip 3, which is to capture metrics and logs, which seems pretty self-explanatory, but I actually find that this is something a lot of people forget about. So I recommend blanket enabling CloudWatch logging and alerting. Sorry, there's a bit of a mess up on the slide there, but set up common CloudWatch metric rules. So something that I reckon everybody should do at the start of their projects is to go and create a CloudWatch alarm to look for the MQTT protocol, and when a ping success doesn't occur over the course of a minute. So what this means is the device disconnects from IoT Core for more than a minute, then you want to publish a notification. So what I like to do as well is use AWS Chatbot integrated with Slack, and I actually receive a notification in Slack whenever one of my devices goes offline for more than a minute. It allows me to help investigate that really quickly. It's quick turnaround. I understand, oh, there's an actual problem. I need to like log in, work out what the device is, and go maybe restart it or something along those lines. So it is also probably going to be pretty verbose though. If you have thousands of devices, if thousands of devices go offline, you might receive thousands of chatbot spam into your Slack channel. So be aware this might not be the solution for everything. Okay, so let's talk about custom metrics now. So let's, for example, maybe we want to work out how toasty, or what the toastiness of toast is that's coming out of our toaster. We can make use of these things for custom metrics. So we could have our devices periodically push out information about how toasty the toast is inside to CloudWatch metrics. Now, why CloudWatch metrics? Well, it's a managed service provided by AWS. It's already tightly integrated with the permissions that you've got on your IoT core certificates. So in my mind, it makes a lot of sense just to publish metrics to CloudWatch, because then you also get to make use of some really simple things like anomaly detection that's enabled out of the box if you'd like it to be. So there's no needing to get a data team to go do anomaly detection or hire a team to go work on that. You can just enable anomaly detection on an incoming stream of data, and you'll get notifications. Now, it might not be perfect, but for a stage 1 proof of concept, something that you're productionizing, perhaps it makes a lot of sense to just enable it. It will allow you to optimize your toasting times as well. So this is all feedback that help you improve your product. IoT logging is something as well that I think is severely underrated. By default, I believe it's only set up to log error. However, when you're designing a product, I highly recommend just going to the IoT core settings and switching that verbosity up to error. Up to info, for example, because a lot of the times when you're having problems, it's really difficult to work out where things are going wrong. You can just simply go to the IoT core logging group and view all the information, details about what's going on in IoT core. It's really handy, but yeah, I highly recommend changing that verbosity to info so you do get a little bit more context about what's going on. But when you do go to production, swap that verbosity back to error and maybe have some notifications around problems when they do spit out errors. Now this is, I guess, not very new now, but IoT logging version 2 is out as well, and all the logs come out as JSON format. So prior to this, they weren't in a JSON format in version 1, but I think by default now it is on logging version 2. So okay, so let's say we're in our kitchen and we've got our toaster there, and maybe we've got a cat, and that cat loves to get into the kitchen and try to mess with the toaster, for example. So maybe we want to do some image classification to detect when a cat approaches the toaster and turn off the toaster. Well, that's actually something we can do using the image classification engine for Greengrass Connector. So what this means is we could have a detector using the default connector for like a cat detector, for example, and we could train a model based on like cats and deploy it to the edge onto our toaster to publish, or basically have an event that when a cat is detected, turn the toaster's power off. And this all could come from a custom metric as well. So I guess the world is sort of your oyster. You can do a lot, and I highly recommend checking out the Greengrass connectors if you do end up running Greengrass on whatever device you do deploy. The connectors will save you a lot of dev time. They kind of bundle up a lot of standard things that you might want to do with Greengrass. So things like reading from a pin on a Raspberry Pi, or connecting a webcam. All of that could be handled through a connector rather than you writing any custom code yourself. Number 4, we're going to talk about detecting and reacting and how we can do that. So when using when you want to detect and react to something, I highly recommend checking out Device Defender security profiles. So here, basically, you're going to come along and you'll define a good and a bad behavior. For starters, I should recommend you will need to install the Device Defender agent onto whatever device you're running. So it's basically a simple little Python script. You can also write your own custom Device Defender agent. All it is basically publishing periodically a set of data back to a IoT Core shadow for your device. If you want more information about that, definitely check out the documentation. The idea behind this is that you define good and bad behaviors. So on the right here, I've defined things like packet exfiltration or perhaps a destination CIDR that we know that our device should be talking to. And if we're not talking to that CIDR, we've got a problem and we need to go investigate. So a lot of the times these behaviors are going to be pretty custom to your business use case. So they won't always be sort of black and white. It's going to be kind of gray. You need to discuss with the product owners and your domain experts to understand what exactly you want to define as a potential problem. These profiles can be like guardrails too. So these can be things that you apply and force apply to all your teams in your organization so that everyone is compliant, and when there are problems, you know that at least you've covered your ass a little bit. So here are some of the results of device defender security profiles. So this here, we've had an alarm sound because we had a lot of packets outbound to an unknown IP address. So this could be somebody trying to exfiltrate data over a port that you didn't allow. It might be worth investigating, like, did somebody get onto that device? And if they did, what did they do? Well, you can actually go through all those packets. We noticed we had like 276,000 packets potentially exfiltrated. So again, you could use this on the flip side too. You could know that your device has to be sending this amount of data, and when it sends less than that amount of data, you want to set up an alarm. That's something you can write yourself. It's totally up to you. You can write a lot of really cool custom rules. So another point to bring up is mitigation actions. So on top of your rules, your detection rules, you can have automated compliance actions that will run. So these are sort of potentially scripts that bring devices back into compliance. So it can do things like remove policy permissions that might be attached to a device. It can rotate certificates, and it can also send notifications. So a common pattern you might see in the wild is when a device potentially becomes compromised, the certificates are actually rotated out, and if you've got a mechanism to put new certs, or better yet, you put the actual device into a quarantine group which has less policies. So maybe the device is no longer able to send and receive data, but you're still able to connect to it, so you're able to do your management, but you've popped the device into a group that doesn't allow it to do any more damage if it. And the final tip that I like to bring up is just keep things updated. So in this case, we might have a toaster, and that toaster is on fire. Oh no, we've rolled an update out and it's caused havoc. It's caused a huge problem. We need to quickly roll back or patch an update out on these devices. But the device is no longer in the field, it's no longer in our office. So how do we keep those devices updated? Well, we can actually use over-the-air updates, which leverage IoT jobs under the hood. IoT updates, or OTA updates, I should say, are supported on Greengrass Core and on AWS FreeRTOS. However, if you don't use either of those sort of frameworks, you can still write your own custom methods of doing this. But if you're using Greengrass Core or FreeRTOS, you're going to get this functionality out of the box. So as you can see on the right there, you can create a software update job. You'd put your firmware into a bucket that you control, and then you can tell the device to begin a update based on the parameters you provided. So on the right there, I'm actually just showing a simple way of updating Greengrass Core. So this isn't necessarily an update of the software running on the device I've got, but it's an update of Greengrass itself on my device. So this process could also be automated, so you could have a script run through like an entire group of devices and maybe do 10 at a time, and as long as all 10 succeed, then you move on to the next one. So you target this job with a thing group, so you could have a thing group called toasters in Perth or something like that. That's probably a bad example, but you could have a toasters in Perth group, and you could roll an update out to all toasters in Perth that need this critical update. And that's the end of this presentation. So I've got a few links here that I recommend you check out. We've got the AWS Greengrass CDK repository. It's all open source and it'll allow you to deploy a CDK Greengrass stack that will kind of get you all set up, and you could potentially use in production without too much issue. I've also got a series of blog posts, AWS Greengrass blog post series. The one I've linked here is just the Greengrass device setup, which is sort of the first blog post in the series. You can use that post to sort of kickstart and move on to other posts after that. So if you have any other questions, though, you can hit me up on Twitter. My handle is Nathan Glover AUS, and I'll put a link up on the screen as well. So without further ado, I guess, thank you, and I'm going to hand over to question time. If you have any questions, feel free to ask me. And again, thank you.